Welcome to Monday's Mental Mistakes. This week we're looking at insensitivity to sample size. Insensitivity to sample size is the tendency to overestimate the homogeneity of small samples. That is, we tend to assume that small samples are more representative than they really are. Insensitivity to sample size makes us more likely to see small samples as accurately reflecting the population from which they come. At the same time, we're unlikely to recognise how important size is to the representativeness of a sample. Here's a simple example. In my local shopping centre, there are two shops that sell lottery tickets. One is large, centrally located with a lot of business. The other is a small kiosk with fewer customers. One has a sign up stating that their customers average much higher lottery winnings than the state average. Which shop is more likely to be able to boast this? The small shop or the large shop? Or are they both equally likely? If your intuition wasn't that the smaller shop was more likely, then congratulations. You suffer from insensitivity to sample size, like the rest of us. As the smaller shop has fewer customers, it is more likely than the large shop to have an above average result. That is, the average winnings of its customers is more likely to not conform to the overall state average. The larger shop is likely to conform more closely to the state average, as its customers form a larger sample. The principal way to counter insensitivity to sample size is to always consider the size of the sample in consideration, and to recognise that the smaller the sample, the larger the effect would have to be distinguishable from chance. While this is well understood mathematically, even without training in statistics, there are some useful rules of thumb. Any sample size in the single digits establishes pretty much nothing. A sample size in double digits is weak evidence and needs further confirmation. A sample size in triple digits is good evidence and is probably reliable if nothing argues against it. A sample size of more than 1,000 is as good as it gets for most things. Insensitivity to sample size highlights the dilemma posed by weak evidence. Suppose that you travel a different route to work one day, but find it slightly slower as the traffic is worse. The next day, your boss calls you as you're about to leave and tells you that he really needs you to be on time, if not early, as something important has come up. The question is, should you take the new route or your old route? The dilemma is that you only have a sample of one journey going the new route, so it is quite likely that the time it took you was unrepresentative of how long it would normally take. Based on this, it may be tempting to try the new route, but that would actually be a bad choice. The best estimate you have of the time that the new route will take is simply the same as it did yesterday. Without further information, there is no reason to conclude otherwise. The seeming paradox is that we must acknowledge that while that is the best estimate, it is still a very poor estimate. That is, the most likely travel time is the same as yesterday, but it's still not very probable. Small samples often put us in a situation where our best estimate is still more likely to be wrong than right, which is part of why we can be insensitive to sample sizes. A good example of how sample sizes can cause unintuitive results is with regards to school performance. It is often the case that when assessing how well various schools perform, that rural schools are amongst both the highest and lowest performing schools. Why is this so? One factor is that rural schools are often smaller than urban schools, and so will have a higher variation in their performance simply due to chance. Our tendency to assume that there is some other, more meaningful factor is the result of our insensitivity to sample size. In conclusion, insensitivity to sample size is a tendency to overestimate how representative a small sample is. Until next week, may your mental mistakes be minor.